We're just gonna wait like 3 more minutes to see if anyone else is joining, and then we'll get started.
I don't think Joe's going to join.
Okay, well, we're still waiting for Kobe and Jeremiah.
Okay.
All right, I was looking at the participants, and it looks like we have a new student with us today. So I'll just quickly introduce myself in this course. So I'm Jane. I am a college student, and I am teaching the programming components for this course. So on Tuesdays, you'll meet with me, and we'll go through PowerPoints learning about Python programming. And then on Fridays, your instructor will be Gael, and he will be teaching you more about the robotics and the aerospace science that goes into getting ready for this competition. So yeah, that's the general gist of things. So now it's Ty, right? Okay, I'm gonna hope that that pronunciation was right. You can correct me if I'm wrong. So do you have any experience at all with Python? Which it doesn't matter if you don't, most of the students in the class don't, but I wanna make sure that I gear your assignments towards your experience. Are you there, Ty?
Yeah, sorry, I had my volume muted.
Oh, sorry.
So I did catch the end of your question. You're asking if I knew any Python, right?
Yeah.
I learned a little bit over the summer. I wouldn't say I'm amazing at it or anything, but I know a couple of the basics. So
Okay, cool. Yeah, we're kind of all over the map here. There's some students who have been working with me on Python for like a year now, and then most of the students don't have any experience. So it looks like we have some more people now. So I'm just going to jump in to the first PowerPoint, the one that we did on Friday. I just want to review it really quickly, and then we will jump into a new PowerPoint. So yeah, let's just get started with that. I'm going to go through the Friday PowerPoint rather quickly because I think most of you have already seen it. Oh no, I don't want this one. I want the other one. I think most of you have already seen it, so I don't want to bore you, but I want to make sure that we're all caught up and on the same page, and I think it'll be a good review too. So let me just close this out and save this. Sure, and then this I should be able to present. All right, so this is just a very basic intro to Python. And again, I'm going to go through it pretty quickly just because we already saw this. This is just a review, but I will post, I'll send you guys an email with a link to both the PowerPoints that we're talking about today So you guys can go through it if you have any questions. Okay, so the number one most important thing that we talked about last week was variables. It's how your computer remembers information. So I like to think of variables like labeled buckets. So you can put things in, take things out. You can just peek in there and check what's in there. And you can change them out, sort them out. So each variable you label and then you put something in it. There are many different kind of things that you can put in it. We'll actually learn about a fifth type of variable later today, but there's just the beginner four, or ints, doubles, strings, and bools. So an int is just any whole number. -2 would be an int, 7 would be an int. Int is short for integer. A double is any number with decimals, so that's like 3.14159, pi, or just like a random, just any number with decimals. A string is a word or a sentence. So like if I wanted to make Jane a variable, that would be a string. I can make hi, my name is Jane a variable, but also be a string. And then a bool will just display either true or false. And we'll learn a little bit more about those when we go over conditionals. Hold on, it's hiding my mouse from me. Let me just sort this. I'd rather. Oh, okay. Someone messaged me saying that they can't hear me. Is anyone else having trouble hearing me?
I'm good.
Okay.
I can hear you.
Okay, cool. It looks like this person might be in the car and not able to hear me because of the background noise. So we'll post this recording and you can come back and watch it at a time that works better for you. So one important thing to know with strings and variables in general is you can't put spaces in the name of your variables. So we see here, we're setting a bunch of different variables. This is the name of the variable, that's what we're putting in it. So we have a bucket labeled month, we put 10 in it. That would be an int. We have a bucket labeled pi, we put pi in it. That would be a double. And then we have a bucket labeled class. We put ARC robotics in it. And this is a string. So one thing that you should take note of, again, there is allowed a space in the string variable that goes inside the bucket, but for the label there, you can't have any spaces. So if I wanted to have my class, I could do that, but I would need an underscore like that. Again, just moving really quickly, the print function, that will just spit out whatever's in the variable. You could also just directly type something that I wanted to be printed. Like if I wanted to print hello, that's how I would do it. But you have to make sure to remember those quotation marks. So print will just print. So this would print, 3.14159, whatever. Oops, that's not what I wanted. I wanted an arrow. And class would print IRC robotics, right? And finally, simple operations. You can add, subtract, multiply, and divide numbers or variables that store numbers. So month is an int and pi is a double, right? So we can add them together. And if I remember, yeah, month was 10. So we would get, this would be 13.1415. You can also add a non-variable number to a variable. So I'm going to take this out for a second. So this month plus 1 would just be the number 11. Now, if I wanted to take 10 out of my month bucket and put 11 in, say it's November 1st, I'm changing the information on my computer, then I would have to add this month equals month plus 1. So this is just going to give you the number. You need this equal in order to put that number back in the bucket, if that makes sense. And there is a shorthand way to do this. You could just do plus equals 1. So before we move on to the next, I know I'm going super fast. I promise I won't go this fast when we're learning the new material, but does anyone have any quick follow-up questions from last week on that section before we move on? Okay, I'm going to take that as a good sign and go on to if statements. So if statements, you use something called a conditional, which is basically anything that's either true or false, right? A conditional usually, it doesn't have to, but it usually is comparing two things using these symbols. So we have greater than or equal to, and what's important here is you have to remember to use two equal signs because if we go back to where we were setting variables, here we're using one equal sign. So that singular equal sign is like the universal symbol for putting something inside of a bucket or setting a variable. So if you try to compare two things, like if I wanted to compare if month was equal to 10, and I wrote that as a conditional, it wouldn't be comparing, if I only used one equal sign, it wouldn't be comparing month and the number 10, it would be setting month to the number 10. So you have to remember, if you're comparing two things, you need two equal signs. If you're setting one thing, you need one equal sign. This exclamation point is the not equal to sign. So like checking if your variable is not equal to 10. And then we have less than or equal to and less than. So we can see here 5 greater than 10, or 10 greater than 5, that's true. 5 less than 5, that's actually going to be false. We need that other equal sign there in order for that to be true. 10 equals month, that's true, right? If we go back here, month is 10. And then Friday, this was a bool that we set over here and we set it to true. So that Friday variable is going to be marked as true. So we can use bools as our conditionals in our if statements, which we're going to talk about here. So an if statement contains two main components, a conditional and the body. So the computer executes the body if the conditional is true. So if I set a number equal to 5, or sorry, an int equal to 5, I call it num. This will say if num is less than or equal to 5, I'm going to print the number is less than or equal to 5. Right, let me see down here. That is the case because 5 is less than or equal to 5, so we're going to see that output there. We can also add an else to our if statement. So we have if num is equals 5, or we set num equal to 5, and then we do if num is less than 5, print the number is less than 5, else print the number is greater than or equal to 5. So we only ever do one or the other. We never do both. And if the conditional is true, then we do the if. If the conditional is false, then we do the else. So we see here 5 is not strictly, this would be what we call strictly less than, and 5 is not strictly less than 5 because they're the same. So we're going to do this else, and we're going to say the number is greater than or equal to 5. An important thing to remember is you can have an if statement by itself without an else statement, but you can't have an else statement by itself without the if statement, right? Because you'll see here the else, this is going to have no, this has no conditional, so there's no way for it to figure out whether or not to do it if it doesn't have the if. Also just important, if you want to take note of the syntax that I'm using here, we already went over this syntax of how to set a variable. But here, I think the two most important takeaways are that you're using this colon after your conditional, or after the else, in that case, the else. And then for the body of the function, we have to remember to, or the body of the if statement, we have to remember to try and indent that. And then finally, we have elif. This is like else if or otherwise. So you see, actually, this is all three of them together in action. We have if conditional action number 1, elif conditional action number 2, else action number 3. So you would, if you were like trying to read or understand someone's code and you got to something like this, if this conditional is true, conditional number 1 is true, then we're going to do action number 1, and we're going to absolutely skip over elif and else. So even if both if and this elif are both true, we're still only going to do the first one that we encounter, right? So if I can get my little drawing tool up, so we move down like this, and we're only doing one action, right? So if this is true and this is true, we're only doing action number 1, right? If I clear it, if this is false and this is true, then we're only doing action number 2. Well, I'm not very accurate with this drawing. And then finally, if this is false and this is false, then we're doing this, right? So the main takeaway here is we go through in order. It's a very specific order. And the first time we find a true conditional, we do that action and we ignore everything else after it. Even if there are a million true conditionals after that, we're still going to ignore all of them if they're labeled with elif. If I got rid of this L and it was just if this and if this, then it would be possible to do both of them. But when I have this important else or otherwise, right, you need to make sure that you're only doing one of them. Does anyone have any questions on that? Sorry, I know I'm going super fast, but I'm going to post these notes, and there's also a recording from when I went over this last week that you can watch if I'm going a little bit too fast for you. Okay, so here we have an activity. We're actually going to save this. I'm still waiting for the right time. We need to make sure everyone has the IDE downloaded, which is basically the app that you put on your computer that allows you to code in Python. But I don't think you all have it downloaded yet. So we'll work on downloading that for everyone on Friday. And for now, once we have that downloaded, we'll go back and do all of these activities. But for now, I'm not going to have some students do it and other students just sit quietly. And I don't want to spend time talking about the downloads. We're going to skip this for now, come back to it, and then move on to while loops. So while loops are very similar to if statements, except there's no like it, elif, or else. It's just one singular while loop, and we repeat the action over and over and over again. Right, so they also use conditionals like if statements. The while loop will execute their body as long as the conditional is true, right? So if I have a conditional where, I mean, we could put it in like human terms. If I tell you, yeah, see here, I have it here. If statement is you can watch TV if you finished your homework, right? So that would, you just sit down and watch TV once. But the while loop would be as long as it's raining, you can stay inside and watch TV. So you continue, right? If someone tells you that, you're going to continue to watch TV and watch TV and watch TV until it's not raining anymore, right? Until this first conditional bit becomes false. So one thing to keep in mind with these is infinite loops. Yeah, I will probably show you one just as a like random example, and it's not going to do too much. It's not going to do any damage to my computer. But if you're dealing with like huge important numbers and like giant matrices with a bunch of data, you really want to avoid these infinite loops. And basically an infinite loop is a loop whose conditional can never be false. So if I have while 10 is greater than 5, print hello, I'm going to have infinitely many hellos. My computer is going to continue to say hello to me until I shut it down. And the way to avoid this is if our conditional is comparing two things together, we need to make sure that at least one of them is changing so that eventually the conditional is going to be false. So for example, if I'm printing it's not December while my month variable is not equal to 12, I have to have a line in my body that adds 1 to the month. So we'll see this over here, right? So I have month equals 10, while month is not equal to 12, it's not December. That's where we print out it's not December. And then I do month plus equals 1. So if I have a month 10 and I'm doing month plus equals 1, what is month going to be equal to when I go back up to line 3?
$11.
Right, perfect. So now month is 11. 11 is still not equal to 12. So this is true. So we're going to do this. Print 4, it's not December. That's where we get this, it's not December. And then we're going to add one more to 11, which is of course 12. Now at this point, I go up to my conditional, and my conditional is asking if 12 is not equal to 12, and that's false. So we're going to move on and we're going to print it's December. And then here is just another example of that, except I added an if and an elif statement in there to print each individual month. You can take a look at this if you want. Another takeaway here, again, with the syntax, we have to remember to do the colon after our conditional and indent everything. Here we have a double indent because we have an if statement nested inside of a while loop. So this if statement is part of the while loop, so it has the while loop indent. And then this line here is both part of the while loop and the if statement. So we see it has 2 full indents there. Okay, so that in 20 minutes, we covered what we did in an hour on Friday. So if anyone has any quick questions, I can answer them right now. But otherwise, I'll post this whole PowerPoint on, I don't know if my boss has made a classroom for this class yet. So if there isn't a classroom, then I'll just email it to you guys. I'll also email you the recording of me going more in depth on Friday, from when I taught this on Friday, that is. And then we'll also go back and do these 2 activities in there once everyone has their IDE downloaded. So that'll be a good review. So does anyone have any quick questions before I switch PowerPoints?
Hi, Jen.
Yes, hi.
So do they have access to the Canvas class or the Google Classroom class?
Not yet. I didn't send out any invites. The information on the Canvas is geared towards Python programming instruction for elementary school students. So the PowerPoints move at a much slower pace, and I think they would be hard to get through. If you want, I can create a new Google Classroom to have all of these like higher level PowerPoints.
So I'm trying to figure out which where to add someone like someone like Ty and Juwaria. where can you add them so at least they can catch up with the programming?
What about the Python 102 class?
Okay, you can add them there too.
Okay, I'll do that after.
All right, and then maybe I know you were saying about the PowerPoints. Where do you plan to post that?
I'll put, if everyone is added to Python 102, I'll post these PowerPoints in Python 102.
Okay, all right, awesome.
All right, perfect. Okay.
And one more thing is also just to get let you all know, the recording for the sessions are posted on the YouTube channel. So you can always subscribe to the YouTube channel or go to the YouTube channel to watch the video recordings. And also you have access to the recording for today's class.
Yeah, if you guys have any questions about what I just covered in the last like 20 minutes, I would really recommend going to the YouTube channel and watching the lecture from Friday, October 1st, because that was this exact PowerPoint, but I just went into much more detail, wasn't talking as fast. Also, I promise it's not always just me spitting 100 words per minute at you. Usually it would be a lot more activities and interactive and polls and stuff like that. But we're just having to put a temporary hold, hopefully only for one more day, on the activities, again, just until everyone gets that IDE downloaded. So now we're ready to switch PowerPoints. And this should be new information for everyone in terms of what we've gone over in this course so far, Sam and Joe. I think you guys have already seen this, but I think it'll be really good review. All right, so here we go. All right. So now we're going to talk about lists and for loops. As I kind of foreshadowed in the beginning of class, lists are our list is the fifth type of variable that we're going to be talking about in this class, and then for loops is the second type of loop. Right? We already talked about while loops. Now we're going to for loops, and for loops are a little bit more complicated than while loops, but I personally think that I use them more, and I think that they're more common in code. Although, like in every code I write, I use like 10 if statements and 10 for loops and 7 while loops. So they all will, you'll continue to see them throughout the whole time that you're coding. So starting with lists, a list is a collection of numbers, strings, or other objects in Python. Right? We create a list using these hard brackets. We'll see that on the next slide. We can access a full list or the individual elements. So if I want to print out my full, maybe I have a list with 100 numbers in it. If I want to print out that full list, I can. But if I want to print out the 50th number, then I can use something like this, where I have the name of my list, a bracket, and then the number. And that will give you the element at that position. And then, as we kind of talked about, lists do store variables, right? They store ints and strings and stuff like that, but they also are themselves variables. So it's like a variable and a variable. So this syntax should make everything a little bit clearer. So to create a list, maybe I'll create a new line for this. So this would be the exact Python code that you would use to create this list. So you'll notice it's very similar to creating an int, right? Where we have the name of the variable, one singular equal sign, and then what we want to make that variable into, right? But the one thing that we're going to notice here is these lists are what's showing the computer, these brackets, sorry, are what's showing the computer that this is a list, right? It's like how the computer can tell, it's like the secret language. Now the computer knows I'm making a list. And then the other thing, we have words, so we're going to make sure to put them in quotation marks. Anytime we just have like a loose word that's not a name of something or a name of a function or a variable, we want to make sure to put it in quotation marks. Okay, so let's actually jump into, I'm going to jump into an online compiler to show you guys this in real time. Okay, so I'll stop sharing this, start sharing that. Okay, so I have my list equals, or sorry, it was called groceries. And I believe it was apples, bananas, milk, and eggs. So if I ask my computer to print groceries and I run it, we see over on this side, we get everything. We get apples, bananas, milk, and eggs. Now, if I ask it to print groceries 1, this is going to print the element at the first position in the list. So you're expecting it to be apples, right? Nope, it's bananas, right? What if I try to print groceries 4? Now I'm getting an error. So what's going on? Why this is 4 elements in the list? Why can't I print groceries 4? Well, that's because if we transition, yes. Sam?
You could say it.
Okay. If we transition back to the PowerPoint, we see that the first item in the list is the 0th item. The second item in the list is the first item. The eggs would be 2, and the milk would be 3. So this is called zero-based indexing. At the beginning, I thought that it was kind of useless and pointless, but as I do more with like applications of Python and math and stuff like that, I see that it's actually really important and very helpful for me in a lot of different ways. So it's kind of hard to get used to at first, but it's just one thing that you have to remember. So if I wanted to print groceries 0, we would see apples. If I wanted to print groceries 1, we would get bananas. If I wanted to print groceries 2, we would get eggs. If I wanted to print groceries 3, we would get milk. And if I wanted to print groceries 4, I would get that. That was my error, right? Because there's nothing in this 4th position over there. And then the one last thing with lists is you can change the elements inside of it, right? So if I go back to my Python, maybe I'm in the grocery store. I don't know why I have my list coded in Python instead of just a normal grocery list, but apparently I do. And my mom calls me, she says, by the way, we don't need milk anymore, but we do need cheese. I would go in and I would say groceries. And then I need a number here. Who can tell me what number is milk? Remembering
3.
that apples is 0. Close, right? It's the 3rd thing in the list, but if apples is 0, then bananas is 1, then milk is
2.
right, exactly. So if I make groceries 2 equal to cheese, we can see that will change the list. So let's look at, here's groceries before the change, and here's groceries after the change. And we can run that. Before the change, we got apples, bananas, milk, and eggs. After the change, it's just replacing cheese and groceries 2, which is milk, and we see apples, bananas, cheese, and eggs. So does anyone have any questions about how I managed to change this like that? Okay, I'm going to take that as a no. Yeah, that's it. We will jump back into lists probably next week because there are a lot more things that we can do for lists. But today I just wanted to get out everything that I needed to get out in order for loops to make sense, because for loops use lists. So if we jump back in here. All right, for loops. So a for loop has 3 main components. The first is a variable. It's kind of like computer science convention to call that variable I, but it doesn't have to be I. You can call it everything, but just usually in most cases, you'll see it be called I. And at the start of each loop or iteration, this variable will be equal to a different element in component number 2, the list. So the list is the set of objects that we are moving through. And the variable is set to each element to exactly once. So if the list has 4 elements, the loop will run 4 times. In other words, if I make a loop out of this list, the first time I do the loop, or the first time I execute the, whatever the action is indented under the loop, I is going to be equal to bananas, or I is going to be equal to apples, sorry. And then I'll go back up to the top of the loop and change I to be bananas. And I'll go do all the actions, and then I'll go back up to the top of the loop and change I to eggs. Just run through the actions and then come back up to the top of the loop, and I will be milk. So we'll see that a little bit closer in the next few examples. Yeah, component number 3 is going to be the body. This is just the actions that we're doing. The body usually will incorporate I in some way, but it doesn't have to, and we'll see an example of both. And then finally, there are 3 different like ways that you can create the list that we're using in our for loop. So the first one is using a list that you created earlier in your code. So I am going to go back into my compiler. Hopefully you guys aren't getting too dizzy with all of the window switching that's going on. And here, down here, I'm going to add my for loop. So we start with for I, which is going to be my name of the variable. Again, if I wanted to put variable or, you know, super fragilistic. I don't know, I was moving a long time, but I could put anything there. It's just convention or like what's normal, I guess, what's most people use to use I. And then I have the word in, and then I'm going to have the name of my list. Here for I in groceries. And I have my colon. And the fun thing about the colon is if you type it, your computer knows that it's making a loop and it should automatically indent for you. Okay, so maybe for I in groceries, I want to print, we need I. Okay, so if I run, and I'm going to get rid of these 2 printings. So all we're doing here is we're making our list groceries. We're switching out milk for cheese. And then we're going to go through and do this, and let's see what the output is. Okay, so we need apples, we need bananas, we need cheese, we need eggs, right? How does that work? So I'm going to add a little text back here. Okay, so at iteration 1, iteration is just one run through of the body. So maybe I'll just call it round. Maybe that will be easier. So from round 1 of the loop, who can tell me what I is going to be equal to?
Is that just Apple?
Right, exactly. Right, so round 1, we see I is equal to apples because again, I is going to be equal to everything on the list in order. So round 1, I is equal to apples. So we print, we need apples, right? Round 2, who can tell me what I is equal to? We're moving on from apples and to bananas, right? So now so we take apples out of the bucket and put bananas in the bucket. So now I is equal to bananas. So we get printed, we need bananas. Oop, bananas. Round 3, I is going to be equal to, any guesses? This one's a tricky one. You have to make sure that you're looking at both the first 2 lines of the code.
Cheese?
Cheese, exactly. So I is going to be equal to cheese. We take bananas out. We put cheese back in. And we get we need cheese, right? And then round 4, hopefully you guys have got the pattern down by now. I is going to be equal to eggs. Take cheese out, put eggs in. And we get printed, we need eggs. So that's how we get this output over here. And if you'll notice, it really is like a looping motion. You know, we start here and we go down here. And then we loop up back to the top, change I, go do the end of the rest of the body, move up back to the top, change I again, do the rest of the body, loop up back to the top, change I, do the rest of the body, loop up back to the top, change the I, right? So that is what would happen if you are using a list that you've previously created in your code. Hold on, let me clear these drawings. And I'm going to reshare my other screen. So that's using a list that you've already created. You can also just make the list right in the for loop, right? So let's put this in our compiler. So I can also just do for, remember we need the for, we need the name of our variable, we need the word in, and then we need our list. So I'm just going to create this list right in here. And then I'm just going to print I. So who can tell me, okay, my keypad just stopped working. So who can tell me what is going to appear over here when I run this code?
1, 2, 3, 4, 5.
Exactly, right? Run it, we see it. Because we start at the top, I becomes the first element in the list. We print 1, I becomes 2, so we print 2. Back up the top, I becomes 3, we print 3. Back at the top, I becomes 4, we print 4. Back up at the top, I becomes 5, we print 5. Now, the third way of creating the list is using something called a range function, right? And we'll talk a lot more about functions in probably next week or the week after. But for right now, you don't need to think too much about the word that I'm saying, but it will make a lot of sense to you in like 2 weeks. But we use something called the range function. So let's say I wanted to print out the first 1 million numbers. It would take me a really long time to have to go 5, 6, 7. Right? That's annoying. I shouldn't have to do that. So programmers invented a little tool that we can use called the range function. So the range function is going to do is it creates a list starting at 0 and ending at 1 minus the number in parentheses. So if you'll see, I'm going to type a comment. Basically, if you type anything in Python surrounded by these 3 quotation marks on either side, it won't be counted as part of your code. It's just like a comment used so that the different computer scientists working on making the code can talk to each other. So whatever I type in here is not going to be run. It's just like a little note that I can leave for myself in English. If you have just one thing that's going to take up 1 line, use the pound key or the hashtag, and you can get that. Anyway, just a little aside so you don't get confused. So range 100 is going to create a list, is the same as me making a list from 0, 1, 2, on and on until I have 98, 99. So if you see, so if I print this, I'm going to see exactly that. I'm going to see 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way 90, 97, 98, 99, right? Again, this is just another one of those instances where you have to think about the 0-based indexing and how basically everything with lists is going to start with 0. So when you do range, you will get 100. You will get starting at 0, ending at 99. Now, if I wanted 1, 2, 3, 4, 5, all the way to 100 exactly, I could just put this in here. So now 0 plus 1 is going to be, this is going to be 1. 1 plus 1 is going to be 2. 2 plus 1 is going to be 3. So every number is just moving up a little bit until I get to 98 plus 1, 99, 99 plus 1, 100. So we run this. And then, yeah, there we go. So we have 1 all the way through 100, right? So this is going to save you a lot of time. Another thing, the last thing that we have to talk about is why would we need to make a loop that doesn't use I, right? That doesn't really use anything in the list. Well, we might do that if we want to do something 100 times. Maybe I want to say, hello world 100 times. How about I do that? I would have this number here. I want it to be done 100 times. I would go that. And then now we have hello world 100 times. So if you're asking, Jane, range 10 only goes up to 99. Why do we know that it's 100 times? Because it's, time 1, 2, 3, 4, 5, all the way to 99. And then you have to remember that there's also time 0, right? So like if I did, all right, let me print this. So we have 0, we're printing that, hello world, 1, 2, right? So this does total, if we take 1 through 99, right? That's gonna be 99 times, and then we add the 0, it's gonna be 100 times. So whatever this number, if we're not using I at all, whatever this number is here is the number of times we are going to run the body of the function. Now I know someone told me last week that they couldn't stay for any extra time in the meeting. So we're really close to right on time. It's 6:43 now. So before we go, we have like 2 minutes for questions. Is there anything that wasn't clear?
Oh
Again,
yeah, just to clarify, elif is else if, right?
Yes.
But how is it different from if else again?
So if else, if, we'll do this. So I'm creating an int.
Oh, you're not sharing your screen.
Oh, sorry. Thank you. Okay, so I'm creating an int, and then I have if num equals 10, print, or if num is greater than 10, print num is greater than 10, else we're gonna print num is less than 10, right? So this is an if else, right? It has two different, it's 4 lines. It's there are 2 different separate bodies, and it will do this if this is true and this if this is false. So if we run this, we get num is less than 10, right? Because 9 is not greater than 10. If we add an elif, so an elif is just 1 line, right? And it's saying else if, or basically if this is false, then try this.
Oh, so you're able to use it for both of those codes, either one, right?
We know that this elif does not replace the if and the else. The if is saying, if this is right, if this is true, do this. Otherwise, do this. The elif is something that you add, that's like a supplementary thing that can be added on to an if statement, that says, okay, that was wrong, now try this. So an elif cannot be by itself. An elif has to be underneath an if, because this is saying if the thing above me is wrong, try this, right? So there needs to be something above it in order for it to run, right? So if I got rid of this and I just had an elif by itself, it would be a mistake. So if we go here, num is 9, num is not greater than 10, so this is wrong. So we're going to skip line 3, and then we come here and we see elif or otherwise try, is num greater than 5? That's true, right? So when I run it, I should get this. Now, if I have this, you guys can read those for a second and then tell me what you think will get printed when I have this code.
It will print. It will print number is greater than 7.
Right, exactly. Remember, even though both of these are technically true, we're still only doing the first one that we encounter that's true. So even though both of these are true, we're still only getting this. Does anyone else have any questions? Okay, then in that case, I promise from now on, it's not just going to be me talking at you for 45 minutes. It will become a lot more interactive as soon as we can get everyone to download their IDE. So again, you should all be getting an email from me inviting you to join a Google Classroom, hopefully by the end of the night. If you accept that email or accept that invitation link, you will be able to see all of the PowerPoints that I've done. And I'll try to link the recording from YouTube too. So if you are confused about the first part of the lecture, I really would recommend going and rewatching Friday's recording, because I went through that PowerPoint in much greater detail. Does anyone have anything else before we all sign off? Okay, great. I'll see you all on Friday.
Thank you.
Bye.